Everyone, I welcome you to this particular lecture. In this lecture, actually, we are going to discuss about the cloud computing architecture. Again, you will find several architecture, like I mentioned you about the John von Neumann architecture, which is a very popular architecture. So, in that architecture, you have seen we have some important components like input, we have output, and we have CPU. Inside CPU, we have arithmetic logic unit, and we have control unit, we have memory, right? Similarly, you have also seen OSI ISO reference model. It is also a standard model. So in OSI ISO reference model, you have seen 7 different layers, and you know the responsibility of each and every individual layer in computer network. And each layer is responsible for some task, and they are dependent on other layers as well. So like that, we have a architecture that is called as a market oriented cloud architecture. So this picture what I am showing here, it is a market oriented cloud architecture. Several architectures you can find in different books, but this architecture is one of the popular architecture. Like OSI ISO reference model, we have 7 different layers. Here you can find we have 4 different layers, right? So the first layer you can consider is user and broker. So this is the first layer. You can see there are different colored icons are there, right? You can say the first 4 are the user and the next 3 are the broker, right? So the difference between user and broker is that broker is on behalf of user, broker is submitting the user request. Suppose if you are not able to submit the request due to you are not aware of that particular technology, or you don't know how to put a particular requirement. So on behalf of you, a broker is going to submit a particular request. So whether the user or broker, they are actually submitting service request from anywhere in the world to the data center, and from the data center we form different clouds, and these requests are processed. That's why you can see in the very first layer we have 2 different icons. One icon is for user, another icon is for broker. But the overall job is that user can directly interact with the system. You can see there is a bi-directional arrow, right? So user can directly interact with the system, or broker can also directly interact with the system. But if user is incapable, then broker is going to do the same thing for the user. Not only that, a user can also submit multiple requests. Like you can see in each and every user icon, we have 2 arrows, right? 2 bi-directional arrows, right? So a user can submit multiple requests at the same time. Like in the last lecture, we have discussed about T2 micro instances. So suppose you need a T2 dot small instance, and you need 2 T2 dot small instance. So simultaneously also you can ask for 2 different type of instances, right? One is T2 micro, one may be T2 nano, one may be T2 large, one may be T2 X large. Such type of instance you can ask at the same time. That's why you can see there is a bi-directional arrow to this particular system. Okay, so user is a external entity. It is not an internal entity. Right? That's why you can see there is a dotted box here, right? We source your cloud infrastructure, but user is outside that particular infrastructure. Okay, user entered to the cloud infrastructure by the help of some service request, right? So user has specific requirements. We have seen also the drawbacks of cloud is that customization is not provided by all the cloud service providers. So So whatever requirement you are giving to the cloud infrastructure, all the whatever requirement you have specified, that requirement may not be provided by a particular cloud service provider. So you have to be little bit flexible. Okay, rather than you can go for example, 2 GB is there, let's say 4 GB is there, but your requirement is 3 GB. So either you have to scale down to 2 GB or you have to scale up to 4 GB. Because customization of 3 GB is not provided by the cloud service provider. Most of the cloud services they are not providing. And even if as a user you need a short-term service, you do not require a long-term service. That's why for a short-term business, why they are going to modify, right? That is also one of the issue. Then the second layer you can see that is called as SLA, resource allocator. And what is SLA here? Can anybody tell what is SLA? Anybody? What is SLA?
So service level agreement.
Yes, SLA means service level agreement between your provider and consumer, which we have discussed in the previous classes also. So the main module in this architecture is your service level agreement resource allocator. You know about SLA. I am not going to discuss much about SLA, but let us see about the resource allocator. Resource means computation is a resources, storage is a resource, network is a resource, bandwidth is a resource, right? So when a customer make a particular request, how you actually map these requests to the resources. Okay, for example, if I show you here, let us take 4 resources R1, R1, R2, R3, and R4. Okay, and user 1 submitted, let's say 2 requests, T1, T2. User 2 submitted 3 requests, let's say T3, T4, and T5. So these are the service requests which we named as T1 to T5, and these are the resources. How actually you are going to map these requests to these resources? That is also important. So a resource allocator job is, suppose let's say this is the resource allocator. The resource allocator is having knowledge of the requirement of each and every task. It knows the requirement of task as well as capacity of the resources. Okay, requirement of the task and capacity of the resources. So what it is doing, it is actually matching the requirement asked by the user with the capacity that a resource can provide. So for example, based upon that, it is decided T1 can be executed in resource number 3, or let's say T2 can be executed in resource number 5. Or sorry, 4 resources means let's say resource number 4. T3 can be assigned to resource number 1, and let's say T4, T5 can be assigned to resource number 2. Okay. So main job of the resource allocator is to do the matching process, mapping process. It has to match, right, which resource is suitable for what type of task. Okay. Task may be different type. There may be a small task, there may be a medium task, there may be a large task, there may be a deadline oriented task, there may be a cost oriented task. So based upon that, it take a decision that which resource is suitable for that particular request, right? So that particular job is done by whom? It is done by your SLA, resource allocator. So you can say it is also act as a interface between whom? Your user and broker and the data center or cloud service provider, or you can say these virtual machines and physical machines, or you can say a set of servers. It is just like an intermediary between two different components. So, but in order to support the service level agreement oriented resource management, what actually it requires? It requires first unit is called as service request examiner and admission control. Service request examiner and admission control. So whatever service request a user has submitted, first it has to check whether it can satisfy that requirement of the user or not. For example, you can see, let us go back to uh, this discussion again. So for example, resource 3 is capable to provide you 4 nodes. Okay, or you can say 4 cores. But the requirement of a task T1, okay, is for five nodes. Assume that. Okay. So if there are 5 nodes is the requirement, and here the maximum node that is available is 4 nodes. Right? Is it possible to satisfy the requirement using resource R3? Is it possible? T1 is asking 5 nodes. It is assigned to resource number R3. But R3 has only 4 available nodes or cores. Is it possible to execute this request in this resource? Say yes or no. Is it possible that if somebody is asking 5 nodes but you have only 4 nodes, can you satisfy that requirement? Say yes or no. Is it possible or not? Can anybody answer? No, it is not possible, right? Because the number of requirements, number of node requirement, it is quite more in comparison to the number of requests available in a particular node. So for this resource allocator has a unit that is called as your service request examiner unit. So the role of this particular unit is to examine the request first. Because if you accept the particular request which you cannot provide, then it leads to SLA violation, right? Or miss of service level agreement. So for which the cloud service provider can be penalized. So in order to avoid that, the resource allocator first checks the requirement of user and availability of the resources in each and every node. Okay, so that is the main purpose of going for request examiner. Now, there is another point it is written that is called as admission control. We have discussed about physical machines and virtual machines. So on top of, let's say, physical machines, on top of a particular physical machine, let's say you have created 2 virtual machines, VM1, another is VM2. Based upon a user requirement, right, you want to deploy another virtual machine on top of this physical machine, right? But when you sum all the requirements of virtual machine 1, virtual machine 2, and for this user, for example, you want to deploy virtual machine 3. So when you want to combine the resources, it exceeds the physical machine resources. For example, rough calculation, I can say this is 2 GB, this is 3 GB, and this is 4 GB. Okay. So suppose here it is available is only 8 GB. Earlier it is 5 GB. The maximum you can provide it another 3 GB, but 4 GB is the requirement. So again, service request examiner will see this particular physical machine is not capable to handle virtual machine. Okay, it is not possible. because some of the requirement exceed the physical network. One more case you can say admission control means on top of the physical machine, how many virtual machines you can create? You cannot go for infinite number of virtual machines. For example, the maximum virtual machines you can create is 2. So if you are getting more requests than 2, then what you will do? You have to decline that request. You have to reject that particular request. Right or not? So admission control unit is responsible for that. Okay. Not only that, they also look into one parameter that is called as quality of service, which we call as QoS. What is quality of service? If you have any specific requirement that you have to fulfill, if user has given some specific requirement, like when you place a order for food, if you have any specific requirement, you are mentioning. So you have to specify that to whether that requirement is very sensitive or less sensitive. If it is very sensitive, so the restaurant has to follow whatever instruction you have given. If it is optional, now in the current system it is optional, right? So the restaurant may follow the instruction given by you, or it may not follow. So quality of service requirement is examined by this particular unit, that is called a service request examiner unit and admission control unit. Based upon that, you take a decision whether to accept a request or to reject the request. So if you have 1% doubt of executing a particular request, simply it is better for rejecting that particular request, so that in later point of time, it is not lead to miss of service level agreement. Is it okay? Another example I can tell you, a non-technical example. One person came to your home. He or she specified that it is a cold season, so he or she requested you to give hot water. It is not mentioned, he or she has not mentioned about hot water or cold water. You can serve any water because there is no specification given by your guest. There is no requirement. But if somebody is specifying that he or she needs hot water, you cannot serve cold water. If you serve cold water, the requirement is not fulfilled. That's why in cloud case, whenever you are going for resource allocation, we consider this quality of service is of 2 types. One is called as high quality of service, another is called as low quality of service. High quality of service says that you have to fulfill the requirement. I need hot water, then you have to provide it. Otherwise, it is you are not satisfying the high quality of service. But if it is optional, okay, if it is optional, maybe any water is okay for your guest, then that is called a low quality of service. So high quality tasks are more costly than low quality of tasks. On the other hand, you can see the chances of acceptance of this request is more in the case of low quality of service. You will not specify the requirement, the chances are more. Cost is also less. And if you are putting some requirement, chances of acceptance is low and cost is high. Right? So such type of requirements are examined by your service request examiner. I hope it is clear to you. So under service request examiner, there are different type of management we have. There are 3 different management you can look here. One is called as customer driven service management. Okay, you have to manage the services in such a manner that customer will attract towards your service. You have to be competitive in the market. You have to be customer oriented. What kind of services is suitable for customer? How much amount the customer can afford? Based upon that, if you make services, then people will attract to your business, right? Similarly, we have computational risk management. Okay, you have to look into the risk factor also. Right? It may be physical threat, it may be virtual threat also. Right? Managing risk management is also important. It may be related to the hardware, it may be related to the software, may be related to different type services also, or it is autonomic resource management. The whole process is complete autonomous, right? Nobody is going to manage these services. User can request a service, the request can be provided from cloud service provider without any human interventions. The system is designed in such a manner that there is no requirement of a human in between the services. Okay. Now you can see other components that are available in service level agreement, that is called as first unit is called as pricing unit. So there are different type of pricing schemes are there. If you go to the pricing schemes, you will find different type of pricing. Like I already mentioned in the previous classes about metered pricing, flat pricing, pay as you go, right? Number of pricing schemes are there. But overall, you can see the pricing schemes are divided into, you can say, peak price. Another is called as your off peak price. Okay. Generally, we consider peak hour is 12 p.m. to 12 a.m. and off peak hours is 12 a.m. to 12 p.m. Okay, it is not only in the cloud case, it is also in the case of mobile providers also. Early days, mobile providers, they are giving offers that you can recharge 9 rupees or 10 rupees, and from night 11 to morning 6 you can talk to anyone uh, unlimited, right? There is no bar for it, because in that particular period of time the service is not used by the regular users, right? That's why here also you can see the peak price and off peak price is decided based upon the working hours, right? Similarly, another type of pricing schemes, you can say it may be fixed by price or it may be changing price. Like while we are taking loan from banks also, bank also asks us either you want fixed price or you want variable price. Fixed price means it will be there whole over a particular period. It will not change. But variable price means it varies with respect to each and every quarter or 3 months. So you have to choose one of the type of pricing schemes. Another pricing schemes, you can say it is based upon supply and demand. That in the regular market also, vegetable market, shopping markets also, we have seen when there is a cyclone or when there is a natural calamity, at that time suddenly the price increases, right? Because the supply is less, demand is more. Sometimes we have seen in the market also, suddenly vegetable prices increase to a big amount. So what is the reason? The main reason is that the supply is very, very less, but the demand is more. So based upon that also you can define the price. Like if you go for one of the real life example of supply and demand, I can say IRCTC. IRCTC introduced a scheme that is called as Premium Tatkal scheme. What is there in the Premium Tatkal scheme? The price increases with respect to time, with respect to availability, with respect to a particular day. Dynamic price is they are charging. Somebody booked a ticket now, it is X price. Somebody booked ticket after 5 minutes, it is X plus plus. Some amount more than X, right? So that is also an example of your supply demand pricing scheme. Similarly, in the cloud case also, people use different pricing schemes. So there are various pricing mechanisms are there. One of the mechanism is called as fixed max. Fixed max is a pricing scheme, which says that you have to pay $3 per CPU per hour. If you have used one virtual CPU, last class I told you about different virtual CPUs. especially in T2 instances, we have seen 1 to 6 or 1 to 8 number of virtual CPUs, right? So per virtual CPU per hour, you have to pay $3. But there is another pricing mechanism which is fixed min, which charges $1 per CPU per hour. So these are examples of which pricing schemes. Can anybody tell? Peak or off peak or fixed or changing or supply and demand? Can anybody tell what kind of pricing schemes these are? Fixed max and fixed min. Out of these 6 pricing schemes, fixed max and fixed min belongs to which pricing scheme?
Fixed max will be for peak hours and fixed mean for off peak hours.
No, that is okay. That you are defining. But these are well-defined pricing mechanisms, right? Yes, if you can go for mapping with peak and off peak price, you can define like that. But these prices are fixed, right? Irrespective of the time. I have not mentioned any time here. I have mentioned simply $3 per CPU per hour. Fixed minimum case $1 per CPU per hour. So obviously this belongs to which scheme? Fixed pricing scheme, right? It is fixed. Whether it is a holiday or it is a normal day, whether it is a festival day or non-festival day, the price is fixed. Then you may ask, everybody will go for fixed min scheme, nobody will go for fixed max scheme. What is the reason? The main reason is the price is less, but the configuration is also less. Like last class we have seen, if you go for T2 small instance and go to T2, let's say X large instance, the configuration is changed, right? The configuration is changed. Even if you are giving one virtual CPU, the configuration of each and every virtual CPU may be also changed. Like you have a processor in your computer system. I have a processor in my computer system. Both the processors are different. So based upon that, they are charging different amount. There is another pricing mechanism that is called as fixed time max. Fixed time max. This scheme charges $1 per CPU per hour like fixed min, but it is in between 12 AM to 12 PM. And $3 per CPU per hour or fixed max in between, like fixed max between 12 PM to 12 AM. The only difference is that it is just a hybrid pricing mechanism. By considering your fixed max and fixed min. Right? For one duration, they are charging $1, another duration, they are charging $3. Similarly, if you go for, there is another scheme called fixed time min. There, they are charging $1 per CPU per hour for off-peak period, or $2 per CPU per hour for 12 PM to 12 AM. That is our peak period. Right? See, different pricing schemes are there. Different resources we have, right? Based upon the resources, we are charging different prices to different resources. And the last pricing scheme is called as Libra plus dollar. Okay, it has 3 pricing schemes, Libra plus dollar. First one is called as Libra plus dollar max, Libra plus dollar min, Libra plus dollar automatic, right? So if you look into these pricing schemes, they consider 2 different factors. In fact, Libra plus dollar takes 2 different factors. One factor is called as alpha, another factor is called as beta. Like I told you, supply demand is also one type of pricing schemes, right? So how you will go to determine this supply and demand? If you go for peak and off peak price is fixed. If you go for fixed and changing, fixed case it is fixed, changing case you can decide in what rate it is going to change. But supply demand, design a pricing scheme for supply and demand is most important. It is most complex task also. How will do? Based upon this alpha and beta factor. What is alpha factor? Alpha is a static factor. Beta is a dynamic factor. Okay, or you can say static component, another is the dynamic component. Like if you see a normal ticket, okay, normal railway ticket, they are charging some seat fare plus some tax. If you go for Tatkal ticket, what they are charging? Seat fare plus Tatkal fare plus tax. If you go for premium Tatkal fare, they are charging seat plus Tatkal fare plus your premium Tatkal fare, which is a dynamic scheme, plus tax. Like that. Like that way, alpha is the static factor. Why it is fixed? If you are not using a particular service, you have to pay the alpha amount. You have not used electricity for 1 day. You are paying the minimum amount, right? But if you use electricity, so in addition to the static fare, you have to pay the beta. So they consider two fare. One is called as P base. That is called base price. P base is $1 per CPU per hour for max and min. Okay, but in order to find the dynamic price, you consider alpha is equal to 1 here, beta is equal to 3 here, alpha is equal to 1 here, beta is equal to 1 here, and this auto scheme follows the Libra plus dollar min. It follows Libra plus dollar min, but it is automatic. Sometimes the values are fixed in that manner, right? To choose a particular pricing scheme. Okay, so in order to calculate the dynamic price, you need these factors. That is very much important. Base price you have to pay, irrespective of the pricing mechanism. Some subscription price is there, you have to pay. But if you need more than that, you have to pay based upon the dynamic price. So such pricing schemes are there in our this architecture, this pricing architecture. Okay. Similarly, we have another component that is called as accounting. What actually accounting does? Accounting means it is going to check how many units you have used over a period of time. Let it be 1 week, let it be 1 month, let it be 1 year. Accordingly, it is going to generate the bill. Like Amazon Web Service case, they are generating the bill per month basis. So accounting unit is responsible for your usage of the resources and price of the resources. Based upon that, they will calculate one. Is it okay? Now come to another unit that is called as a VM monitor, virtual machine monitor. So a virtual machine may be in any state. Okay, if you look into a virtual machine, it may be in any state. Like a virtual machine is doing some work, so it is in active state. Okay, a virtual machine is not doing any work, that means it is in idle state. Okay, a virtual machine is yet to active. Okay, as it is not executing any work, so you can put that in a sleep state, or you can say awake state, sleep/awake state, or it is completely in the shutdown state. So active virtual machines are ready to execute, they are executing some tasks, and if additional resources are there, then you can execute it. But idle means if you assign the work, immediately it will execute. Sleep and awake means it will take some time, Like in our computer system also we have sleep or hibernate. What actually do? It is not completely shut down your system, rather than within a fraction of second it will be in the active state or it will move to the idle state. Okay, and shutdown statements it will take more time to come to the idle state or the active state. So what is the status of each and every virtual machine? That is you can determine from this particular unit. So your VM monitor is responsible for this particular job. Right? Like you can see the third layer is our virtual machines. So which virtual machine is free? Which virtual machine is busy? Which virtual machine can be assigned for a new service request? That you can decide from this VM monitor unit. So this is with respect to the VM, virtual machine. Virtual machine, you can say it is with respect to a provider, cloud service provider. Who takes care of this virtual machine? Your provider only, right? But there is another unit that is called as service request monitor. Suppose thousands of requests are reached to a cloud service provider. So which service request is running? Which service request is queued or waiting? Which service request is terminated? These all status you can get from service request monitoring. Just like you are looking into a window or a dashboard, you have seen that out of 100 requests, how many requests are accepted, how many requests are queued, and how many requests are rejected. So you can say user perspective case, we are interested in the service request monitoring. But provider perspective, they are looking into VM monitoring. Together, we need the mapping of the service request to the virtual machine. Okay. Now, another unit you can see under SLA resource allocator, that is called as your dispatcher. Okay. So you have seen different type of dispatcher in operating system also. Can anybody tell what are the dispatcher you have studied in operating system? What are the different type of dispatcher? Anyone? We study different type of scheduler also in operating system.
Long term and short term.
Exactly. We studied three type of scheduler actually. One is called as long-term scheduler, another is called as medium-term scheduler, another is called short-term scheduler. Right? So due to the smaller size of our main memory, main memory size is quite small in comparison to our secondary memory. So all programs are stored in our secondary memory. So in order to execute finally that program or the data need to be loaded into our main memory. So when they are stored and loaded into the main memory, they are called as processes in operating system. Right? So you have the objective, the main goal behind the long-term scheduler to decide the degree of multi-programming of the system. But it actually maintains the queue to load the different processes into the ready queue. Right? Once it is once it is loaded into the ready queue, short-term scheduler's job is to move from the ready queue to the CPU. And while a process is executing in CPU, it also suppose it requires some kind of I/O input output. Then it is again going to move from CPU to again your I/O waiting queue. Right? CPU to I/O waiting queue. So the scheduler which moves from CPU to I/O waiting queue, they are called as medium-term scheduler. Right? But there is a difference between the scheduler and dispatcher. Okay, because the procedure which adapted for selecting a process among a set of processes, like I told you, there are different tasks are there. They are queued. your SLA resource allocator has to pick a particular request or task from the queue. That is the job of the scheduler. But once the scheduler has selected a particular process from the queue or waiting queue, the dispatcher comes into the picture, okay, because it takes that process to the ready queue, moves it to the running state. Or it is, in our case, cloud case, it is deployed in a particular virtual machine. That is the job of your dispatcher. So dispatcher is not same as your scheduler. Scheduler is picking a particular request. Dispatcher is moving that request from one state to another state. One may be waiting state, another may be running state, another may be ready state. This movement is done by your dispatcher. So you do not confuse between the dispatcher and scheduler, right? So this is all about the SLA resource allocator. And on top, on below that, SLA resource allocator, like I told you in previously also, if you go for the bottom layers of any architecture, in any computer architecture or any technology architecture, bottom architectures are more or less hardware architectures. But if you go for the top layers, these are software architecture. Okay, they are softwares because user uses the cloud by the help of a web browser. Web browser is a software. User uses a terminal in which there is a browser. So the terminal, okay, that operating system is also a software. But provider provides the resources to the user. Provider has to set up the servers. Provider has to create the virtual machines. These all are part of our hardware. So the third layer, which we are looking here, that is called as virtual machine. So you can see, based upon the capacity of the physical machine, you can create the virtual machine. One of the example I'll share you. For example, let us consider this particular server. And let us compare with the second server. Right? So if you compare this particular, by the help of this server, you have created two virtual machines, 1 and 2. But by the help of this one, this particular server, you have created 3 virtual machines. That's why how many virtual machines you can create, that purely depends upon the size of physical machine. The size of physical machine. Okay, if the physical machine size is more, then you can create more virtual machines subjected to it, satisfy all the requirements of the physical virtual machine, and it can manage all the virtual machines. Right? So there are 3 different research problems. If you are interested, you can do. First is how to map the virtual machine with physical machine. Which virtual machine is mapped to which particular physical machine? That is one of the research problems. Why it is important? Because see, I told you one class, if a VM, if a physical machine is there, on top of that you have a virtual machine. There is another physical machine. On top of that you have, let's say, another physical machine is here. You can move this VM from one physical machine to another physical machine without suspending that particular virtual machine, without stopping the work executed in that particular virtual machine. Right? That's why mapping of VM and physical machine is very, very important. Again, if you come to the user perspective, these are nothing but user request. Let's say URs. So mapping of these URs to the physical machines, or let's say PM1 or physical machine 2, or in the physical machines you have virtual machine 1, virtual machine 2, here virtual machine 3, virtual machine 4, and virtual machine 5. It is really challenging. Right? Mapping of URs to physical machine is a problem. Mapping of PM to virtual machine is also a problem. And when data center comes to picture, data center is nothing but a set of physical machines. So together I can call the bottom layer is a data center. So the overall term is called as data center. If you go inside the data center, you will find physical machines or you can say physical machines are nothing but the servers, and inside the physical machines you have virtual machines because they are hosting the virtual machines. Okay, this is the complete architecture of cloud computing, right? So see, there are different type of problems, and service request is there, right? Which I call as user request. Mapping of UR to data center is one problem. Mapping of physical machine to virtual machine is another problem. And mapping of this user request to this machine is another type of problem. So if you go to literature, you can find a number of research problems related to these different type of problems. Okay, so this is the architecture, which is very simple architecture, I can say, from user perspective and your cloud service provider perspective. Right now, let us discuss about more about these pricing schemes. I'll tell you a calculation. Then we'll continue with other discussions. Okay. So I told you pricing Pij. If you want to calculate the price Pij, Pij is nothing but price. Pij, I am taking two index because I can be considered as you can say service request, and J can be considered as node. So in order to calculate price Pij, it is nothing but alpha into P base J plus beta into P utilization of Ij. See, Pij means what? I is for your request. Request is given by whom? User. J is nothing but node, or you can say virtual machine. Machine is going to provide you, your cloud service provider is to provide you a particular node or a virtual machine. So in order to calculate the price of getting a request J and assign it to service request I, you need to calculate the price Pij, which is nothing but alpha into P base J. P base J is base price of using the request J, sorry, base price for using the node J. J index is for the node. Beta into P utilization of Ij says that if ith request is assigned to jth node, ith service request is assigned to jth node, what is the utilization? So further, P utilization of Ij can be calculated as resource maximum J divided by resource free Ij multiplied by P base J. So what is RES max J? It is nothing but maximum unit of the resource at a particular node J. What is resource free Ij? It is nothing but remaining free unit of the resource at node J. If there is a deadline for it, you can also consider it. Now you tell me, you have maximum resources 10. Let us take a rough calculation. For example, you have maximum resources 10, but available resource free is, let's say, out of 10, only 2 nodes are free. You consider another example. 10 is the total number of resources, that is the maximum number of resources. Okay, but out of 10, it is all the nodes are free. Okay, so you see here which one is costlier here? Which one is costlier here? Can anybody tell? Imagine
The first one.
first
The first one.
Exactly, because first one case 10 is the maximum number of nodes. Assume that you have 10 different resources. You are a provider. Out of 10 resources, only 2 resources are free. Means 8 resources are used. 8 resources are already used. That means people are interested in your service. If the resources is exhausted, or eight requests out of 10 is served. What it means? It means that people have interest in your request. So the cost factor which is multiplied is 5. But another provider, if you see, that provider is having 10 nodes, but none of the node is busy. All the nodes are free. Then the cost is 1. Now you map this concept with the IRCTC premium Tatkal scheme, which I told you. Okay. But I told you there, I told you that when the number of seats are less, means over a period of time it is increasing, means number of seats are less. If number of seats are less, automatically the price is going to increase. Okay. And if the seats are not used or seats are vacant, then the price is as usual. Right. Now let us do a small problem. Like I mentioned you about Libra plus dollar scheme, right? Libra plus dollar scheme. In Libra plus dollar max, I told you the alpha factor is equal to 1. Beta factor is equal to 3. So what I can write? I can write Pij is nothing but P base j plus 3 into P util ij. Suppose base price is 10. Let's say base price is 10 plus 3 into your P util of ij. Utilization of ith service request in jth node. And let's say out of 10 nodes, let's say our consider the first scenario. You have maximum 10 different nodes, but only 2 nodes are free. So you will get a factor of 5. If you multiply with the P base j, so in the first example, let it be example 1, example 2 to avoid confusion. So what I can do here, it is nothing but 5 into P base of j is 10. So you are getting 50. So if you put here, you will get 10 plus 3 into 50. So the total price, it may be in INR, it may be in dollar. So you can say it is 160. Am I correct or not? But in the second case, what do you, if you calculate P util of ij, what value you will get here? Can anybody tell what value you will get here? P util of ij.
10.
Yes. It is 1 into base price. It is 10. So you will get 10. Then what is your Pij value? In the example 2. This is for
40.
example 1.
40.
So 10, yes, 10 plus 3 into 10. So you will get 40. So see how drastic change is there. When the number of resources are used is more, the price is drastically increasing. So in this way, if a particular scheme is given to you, you have to remember these vectors. Alpha is equal to how much, beta is equal to how much. Like if the same thing you will calculate for Libra plus dollar minimum, where alpha value is equal to 1, beta value is also 1. So if I calculate Pij, it is 10 is the base price plus the P util of ij. Right? So in example 1, how much you will get? In example 2, how much you will get? Tell me Pij value. Tell me how much you will get.
Example 1 will get 60, and
Okay.
in case of example 2 we will be getting 40.
40. So it is nothing but 10 plus, it is 5 into base price. Base price is 10, so 50. So it is coming as 60. But example 2 case, it is 1, right? So it is 10 plus
20.
10 plus 10. So it is 20, not 40. Okay, because beta value is 1. If beta value is 3, then you are correct. It is 40. So in this way, given a pricing mechanism, you can estimate that what is the utilization. Right? Based upon that utilization, you can charge to your customer. Okay. So let us take a break here. We'll again resume at 11:40. Yeah, my screen is visible.
Yes, sir.
Yeah. Is there any doubt till now? Anyone? Okay. So if there is no doubt, let us continue our discussion with the architecture. So here you can look into another type of architecture which we call as high level architectural approach. We shows you the high level view of the things that are associated with cloud computing, right? So it is, you can say, with respect to how to carry out business, how to maintain various practice, how to maintain various quality parameters. Based upon that, this architecture is suggested. So basically, we divide into it into three different type of, you can say, level. Like previous case, I told you we are divided into 4 layers, but here we divide it into 3 layers. First one is called as your business goal. Second one is called as quality attribute. Third one is called as your architectural practice. So business goals are mainly deal with the company policies and the company management. They actually takes care of the business goals. So business goals covers your TCO. TCO stands for your total cost of ownership, quality, and market share, right? It is also about the equity, stakeholder of the company, and satisfaction level of these of the stakeholder. Stakeholder also contain the user also, and any regulations or any standard, any open standard or any compliance, any jurisdictions. These all are maintained in the business level, or you can say these are the business goal. You can say stakeholder satisfaction is also one of the important business goal. So these are associated with the business goals. Coming to quality attributes, what is the quality attributes in the cloud? Quality attributes means some performance measure. By looking into that performance measure, you can decide whether your target is achieved or not, or whether your performance is good or not. Like for you, your grade point average, extracurricular activity, co-curricular activity, some marks are awarded to you, or some pointers are awarded to you, some point is awarded to you, some credit is awarded to you. So based upon that, you can see overall performance of a particular student. Similar fashion, in the cloud case, if you want to uh, see the quality of each and every attribute, okay, or you can say quality of a particular service, you need to focus on availability, elasticity, interoperability, security, adaptability, performance, usability, and maintainability. These all are associate parameters. Like availability means, you know, the resource need to be available 24/7. Yesterday also we calculated some values with respect to over a 3 period of span. We calculated what is the cost value per hour. Similarly, elasticity says that scale up and scale down. Interoperability says that if it is working in X environment, it should work in the Y environment. Okay, because the libraries APIs may create your problem, but it should not create a problem. Similarly, security, see, it should not be compromised. Privacy should not be leaked. Reputation need to be increased, right? Similarly, adaptability, like if there is a new technology is coming or if there is any upgradation, so it should support. Your provider need to incorporate it, and it should be reflected to the user. You should be adaptable to any particular environment. Similarly, performance, usability, and maintenance, these all are associated with reliability. You can say failure, mean time between failure, mean time to failure, mean time to repair. By looking into these parameters, you can calculate some of the quality attributes. Now, if you coming for last, the bottom layers like architectural practice, you can find stateless design. Okay, there is no specific state. State means in order to keep some information, we have a state. If you want to store some partial result, then also you need a state, right? So there is no specific state because it is completely loosely coupled. It is completely heterogeneous. Because if you need something is state based, so everybody need to incorporate in the system. So there were the considered essentials are whether it is a stateless design, whether we loosely coupled. You can say we are thinking that there are several devices are there in the you can say in the world, and they are connected to each other. So it should be stateless design. It should not be state based design. So it is also loosely coupled. It is casing. It is claim-based authentication. Nowadays, people are focusing on ciphertext-based encryption, attribute-based encryption. These encryption methods are better in comparison to the traditional methods. Similarly, they also rely on one of the architecture that is called a scale-out architecture. Scale-out architecture is also same as you can say horizontal scaling. What do you mean by horizontal scaling and vertical scaling? Like if you see building constructions, suppose a building is having 2 floors and I want to make another floor on top of the second floor. So it is a horizontal scaling or vertical scaling? Can anybody tell? Suppose in a particular building you have some floors, you want to come with adding some floors. So it is a horizontal scaling or vertical scaling? Is it horizontal or vertical?
Vertical scaling.
Vertical scaling, right? So just like in your computer system, you have 2 GB, right? You are adding another 2 GB. Suppose 2 GB of your RAM is there, you are adding another 2 GB. So it is called as your vertical scaling. But what is horizontal scaling? If you combine 2 computer systems. So here, the scale-out architecture is an example of your horizontal scaling, not a vertical scaling. So horizontal scaling says you have to add new hardware to the existing IT systems. Rather than increasing the hardware component, hardware resources, you have to focus on adding new hardware, not to enhance the capacity of a particular hardware. Similarly, we have pipelining concept. You know, pipelining is a very popular concept in which you have 4 pages. You have fetch, you have decode, you have execute, and you have store. So your objective is to make utilize of all the 4 pages. At any point of time, there should be an instruction in each and every page. Earlier case, it is just like a sequential. If one instruction is in the page, it has to go to decode, it has to go to execute, it has to store. Then another instruction will start from the page stage. But due to the pipelining concept, what you can do in each and every page, if a instruction is there in the store page, another instruction may be there in the decode page, another instruction may be in the execute page, another instruction may be in the fetch page, right? So in that way, you can increase the speed of factor, or you can say increase the speed of execution of a set of instructions. We have divide conquer, we have firewall traversal, we have partitioning, pub-sub model. I told you YouTube is an example of pub-sub model or publish subscribe model. You have to subscribe to the channels, and based upon that, any new content is added by the provider, it will be notified to all the subscribers. Similarly, strong encryption, multi-tenancy is another important factor, right? Like interoperability, I told you, right? Interoperability, you have to look into multiple factors. Okay, multi-tenancy, you can say it is an architecture in which you can say a single instance of a software. If you take a software application into consideration, a single instance of the software application serves multiple customers. Like the resources of a single physical machine is used by multiple users by creating virtual machines. So a single instance can be used by multiple people. Like you see our example of a server-based application. In server-based application, the software is installed in the server. Software is installed in the server. When you switch on a computer system, one instance is created in your computer. Another user which is connected to server switched on the system. So the same copy, same instance is also available to that particular user. So the same instance can be used by multiple customers. Similarly, reliable messaging. With respect to messaging also, you have a services in Amazon Web Service. Okay, you can use that services for secure communication between two different users. Similarly, asynchronous communication. These all are coming under the architectural tactics. So they visualize this in the with respect to these three layers. That's why I told you that you will not find a unified architecture in the case of cloud. But market-oriented architecture is a very popular architecture, but this is also one of the high-level architecture. So, as we discussed here, that the major building blocks of the cloud architecture is the technical architecture. So, what is there in the technical architecture? You have structuring according to XaaS stack. Why we call this is a stack? Because you know the concept of stack. One element is suppose push into the stack, so it will be above the previous element. So we maintain one kind of stack like this, right? You can say one layer is above another layer and so on. So we call this XaaS stack because we don't know whether it is infrastructure or platform or combination of infrastructure, platform, or any type of service. And adopting cloud computing paradigm, that is very much important. Most of the organizations are heading to adopt the cloud computing paradigm, so which will help them to grow their business with less cost. That's why they are adopting the cloud computing paradigm. Similarly, structuring cloud services and cloud component. Structuring means you have to enforce some specific type of structure. In what way you are going to provide to the customer. Customer, like different providers are looking for the similar type of structure, so that when a client wants to suppose move from one provider to another provider, the client will not face any kind of difficulty. You see our websites also. Different institutes are having different websites. More or less the site educational institutes you see, the sites are same. They contain the similar type of information, but the functionality is given in different tabs or different sub-tabs or different you can say icons, right? So you have to manage these things, right? You have to make it in a proper way so that the user can easily locate this particular service. Like storage is service, like computation is a service. If you are habituated with one cloud service provider, you can easily get these services. But when you move to another cloud service provider, you are searching for the same option. Similarly, showing relationship and external endpoints, middleware communication. Middleware is specially used for abstraction purpose. It is hiding many internal details. Similarly, management and security. So there are more technically architecture or architecture features for this high-level architecture. Similarly, if you come to the deployment operation architecture, like if you want to go for geolocation check with respect to your, like I want to know about your location. Based upon that, I will deploy the service. Because if you deploy a service which is far away from your place, then you know that communication will take more time. So if I know your location from where the service request is initiated, so I can suggest which particular location is there to provide you that particular request, so that the communication time can be minimized. It is also important to know the legal issues with respect to one region to another region. Also, an expert can control, like if there is a flooding of requests in a particular region, then you can redirect some of the requests to other region. In that way also, you can think the deployment operation architecture. Similarly, you can see operation and monitoring. Okay, that suppose you want to monitor that how many requests are coming to a particular region, whether you need to expand the infrastructure or not. That also you can think by monitoring the different requests, or monitoring the number of requests, and monitoring the capacity of the, you can say, how many requests are currently in use, how many are there for they're available in that particular region. You can take a decision. Similarly, here you can see I have mapped the three different services, that is infrastructure as a service, platform as a service, and software as a service with one architecture. Okay. So here you can see under infrastructure we have storage, like Amazon S3 is a storage, or if you have virtual machines, or you have physical machines, these all are can be mapped to this storage and infrastructure. That is infrastructure as a service. But when you look into the platform as a service, we are focusing on the cloud runtime environment, or fault tolerance also. It can be taken care by the platform as a service, and various services. Load balancer also part of our platform as a service. So with respect to management, they have mapped the three different services with these management type of services, right? Similarly, if you go for software as a service, we look into application, and on top of that, we have client infrastructure. Client infrastructure means, so you can say our terminals, right? Or you can say PCs, workstations. These all are through which you are going to deploy the services. So management and security both are important aspect when you go for different type of services with respect to IaaS, PaaS, and SaaS. Similarly, this is another architecture. If you look into customer view as well as the provider view. Okay. If you recall that example, pizza as a service, I told you, you can map these things, right? Infrastructure as a service case, you have virtual machines and network, right? So platform and software as a service will be taken care by your customer. That means for maintaining the infrastructure as a service, we have IT architect, information technology architect, we have IT operator. But if IaaS is taken care by your cloud service provider, in your company, you need not require IT architect and IT operator. But if platform as a service, if you look into only infrastructure as a service, not platform as a service, not software as a service, so you have to ensure that you have application administrator, you have software architect, you have developer in your company. So they have to take care. Only infrastructure is going to be provided by your cloud service provider. Similarly, if you go for IaaS plus PaaS, platform as a service, both, right? So you need only one application administrator. One of the example you can say, like our email system. I repeatedly use this example. Our email system. For our email system, we need an application administrator, which is admin, who is managing these emails, right? How many emails you want to create, whether the email ID is active or it is suspended, that will be handled by the admin. Rest thing will be taken care by your cloud service provider, like software architect. They will or developer. They will look into the runtime environment. IT architect. They will focus on the infrastructure part. Okay, like Gmail case or our email system case, you know that the servers are not in our campus, not in our institutional boundary. They are managed by Google. They are provider. The provider has to see that how they are going to maintain these emails. That is not our we are not hesitate about that. We are only we are only focusing on the email ID creation, right? As an admin portal, you can create as many email IDs as possible based upon your subscription. And this part you can see we are taking all three: infrastructure as a service, platform, and software. All are from the cloud. So it is just like a stack. On top of IaaS, you have PaaS. On top of PaaS, you have software as a service. So all the three things are given by your provider. So customer did not require any persons to manage either the infrastructure or platform as a service, software as a service. Customer will simply use the services. Rest thing will be taken care by your cloud service provider. Similarly, you know there are different cloud service providers are there. Okay, one cloud service provider is Microsoft, another cloud service provider is Amazon. Okay, we called Microsoft Azure platform. It is a very popular platform. Like Amazon case also, or Amazon Web Service, Amazon EC2. It is a compute cloud. So if you compare these two cloud, right? Although they are providing similar type of applications, but their underlying technology is different. So let us map these two architecture, these two popular cloud services. Okay. So if you compare this, it is also represented in the form of stack. Okay. We divided it into more or less into three different stacks: IaaS, PaaS, and SaaS. Right? Bottom layer is always the infrastructure, top layer is always the software as a service, and intermediate layer is your platform as a service. So if you look into Amazon, so more or less it is having Windows servers. You can see Windows Azure Server 2008 in the case of in the Amazon case, you will get Windows servers or Linux servers, right? EC2 case, you are getting Windows or Linux servers. You can see in the bottom part, it is written either you can take Windows or you can take Linux. But here, it is Windows Azure. It is focusing on only the Windows part. Okay. So the type of infrastructure they are providing may be different. For storage, maybe they are using S3 or simple database or RD for database purpose. S3 is for the storage. But here they are using table store or blob, or they are using for the database perspective, they are using SQL or NTFS system. Okay. So more or less they are providing the same service, but the type of technology they are using, it is different. Similarly, you can see in the platform as a service. Okay, we have seen in the market-oriented architecture related to billing, right? Okay, here also you have billing, right? Or you can say accounting unit. This is there in the both architecture, right? They are using here the .NET framework, right? But the type of framework used in here, maybe it is different. They use notification is also one type of service. Queuing is another service that is used by Amazon Cloud. Similarly, the type of application like CRM, or if you go for video conferencing, or if you want to go for live streaming, such type applications are supported here. Here also, you can deploy some kind of applications. You can go for, if you want to go for your own database, okay, you can go for mechanical Turk. These are type of applications as also you can put in Amazon EC2. So like that, you can compare one architecture with another architecture, right? But type of services they provide, more or less they are same, because both are providing infrastructure platform and a software as a service. Yes, you can see the architecture for elasticity. So there are two type of, you can say, scale up we have, or elasticity is, you can be visualized in two different way. It may be a vertical scale up, it may be a horizontal scale up. Like here you can see, I'm taking a small instance and I'm adding the resources in that particular instance. So more or less what you are doing, add more resources to a single computational unit. So just like this is a small box, now we have a big box. Like earlier it is, let's say 2 GB, now you have enhanced the same capacity to 8 GB, right? So that is called as a vertical scale up. So move a workload to a computational unit with more resource. It is having less resource, but we want more resource, right? So that is called your vertical scale up. So for small scenario, scale up is probably cheaper, or you can say code just works. So for a simple scenario, or if you don't want to scale for a larger amount, right? Like our systems are slower. That's why we put instead of 2 GB, we put 4 GB. So in that case, let's say vertical scale up is good. But when there is a spike in demand, okay, when there is a sudden change, in that case, you should not go for vertical scale up. So horizontal scale out is nothing but adding additional computational unit and having them act in concept. So like here you are using one server, I am adding similar type of servers for your work. Today you have used one server, but you have increased to 10 different servers. So whatever work is done by this particular server, now it is split into 10 different computational unit. Similarly, you can not only computation you can do, but also storage you can divide into 10 different units. You can also do database also, you can divide into 10 different units. So it is suitable for larger scenario. Right? Suddenly you need resources for some period of time, but after that period of time, you again back to your small instance, right? Like you are using, let's say, T2 micro instance or nano instance, you want to increase to some big instance, let's say 16x large instance for a particular period of time. So in that case, you can go for horizontal scale up rather than go for a vertical scale out, right? So for larger scenario, scale out is the only solution. Like 1 cross 64 way server, much more expensive than 64 cross 1 way server. Right? Last class also I told you, purchasing a 12 GB of server and purchasing 1 GB of server. So if you see with respect to cost, 1 GB of server is more costly. Okay, and 12 GB cost one server is less costly. But if you are working in a particular environment where there is a frequent failures are there, okay, in that case, you can say 1 GB of server is better. That's why in this case also they are saying 1 cross 64 way server, much more expensive than 64 one way server. So if there are 64 servers, okay, 64 servers, but another case we have only one server. So you can calculate the cost and you can compare with respect to different parameter which one is a better one. For example, in this case, this is more expensive. So you have to go for 64 cross 1 way of server. So in all the architecture, we address service model, which we called as XaaS, which we called, I told you already, it is anything as a service, or you can say it is everything as a service. So any service model is a combination of service-oriented infrastructure, which we call as SOI, and cloud computing realizes to XaaS. Any type of services you can get from that particular architecture. So in order to generalize the type of services provided by cloud, we call this is a XaaS. So it refers to increasing number of services that are delivered over internet rather than provide locally on site. So through internet, you can provide any kind of services. You can increase the number of services, increase the number of resources in this particular service model. And XaaS is the essence of the cloud computing. And see this, there is another one architecture here you can see. Like on top of SaaS, we added business process as a service, which we called as BPAS. Okay, business process as a service. And together this IaaS, PaaS, SaaS and BPAS, we call that as a XaaS. So XaaS case, what we are doing? You are going for horizontal or vertical business process. Okay, provided on a subscription basis to the companies or industries. You have to take a decision. If a person is working for 8 hours for a company, should I increase it to 16 hours or I have to hire another person who will work for 8 hours? So that is also our horizontal or vertical business process. Similarly, software applications hosted in the cloud and provided on a subscription basis. For that, we have a software as a service. Application deployment environment or runtime environment is provided by platform as a service. And raw infrastructures, hardware like CPU, memory, storage, network. These are provided from the infrastructure as a service as and when required to the customer. Now you can see with respect to you can see some of the examples with respect to these three different type of services. Where I repeatedly tell you that Amazon EC2, Amazon S3 belongs to the infrastructure as a service. Similarly, there is another cloud service provider that is called as Rackspace. Okay, Rackspace offers MOSO, right? So this is also one type of service. Some cloud services are also infrastructure as a service. Terremark is another cloud offering that is also belongs to infrastructure as a service. So in infrastructure case, what do we want? We want hardwares, right? Servers, or you can say databases, storage, networks, right? You may have multiple servers in order to make it redundant, okay, and make access to multiple servers at the same time, multiple redundant servers at the same time. But if you go for platform as a service, Microsoft Azure is a very popular example. Google App Engine is an example. Like there is a company, there is a startup app, and that is related to the bicycle rental, bicycle renting purpose. They have one app is developed in Google App Engine. Okay, the objective of that app is that suppose you need a bicycle, you visited a particular city, right, and you want a bicycle, right? You want a bicycle, so you can check which one is the nearest bicycle. You can say rental shop. So you can search in your application the way you are searching the next petrol station, the next shopping mall near to you, right? Or next anything you want to you need, right? Any hospital also you need nearby. So you are checking that one. Similarly, through Google App Engine also you can do that one, right? They set up a particular application through which you can find the nearest bicycle rental shop, so that you can hire, you can take a bicycle in rental basis, and you can visit that particular city. Nowadays also, if you go to the new cities, now scooters are also available. Many cities are, if you go to that particular city, there is a scooty, you can say shop, right? You can give some nominal amount and they'll give a scooty, and you can visit any place in that particular city, right? So similar applications, if you want to develop and deploy in the cloud, Google App Engine, Microsoft Azure, Host.com, these all are providing the platform as a service. So basically, these are application services which are readily available for deployment. That's why we are going for platform as a service. And these are the examples of our software as a service. We use Google Docs, we use MobileMe, we use OneDrive, we use Google Drive, you use Zoho. Zoho is also one of the example of our software as a service. Okay, here there is no specific state. It is a, as I mentioned, it is a stateless design. Okay, so applications can be hosted in the cloud, and customers can use these applications. They can run multiple instances of that applications, and only they have to pay the subscription price as agreed in the service level agreement. Yes, basically we have three service models as I told you, but these are some of the examples of your XaaS. So on top of this IaaS, PaaS, SaaS, you can include one of these services, like we have seen a diagram that is called as BPSS, Business Process as a Service. Similarly, you can go for a storage as a service, security as a service, database as a service, monitoring or management as a service, communication or content and computing. Okay, that is CaaS as a service. identity as a service, backup as a service, or desktop as a service. I already mentioned you healthcare as a service, agriculture as a service, and sensor as a service. People come up with a different type of services. So the main requirement of CSP is how to increase the end user satisfaction, how to increase the productivity, because if you increase the user satisfaction, number of users are going to increase. More people will attract towards a particular cloud service provider. Not only that, over a period of time, whatever new technologies are coming into the market, okay, as a cloud service provider, you have to adopt such innovations, right? Adopt that particular technology. That will also increase the productivity. Similarly, increase the agility is also the requirement of cloud service provider. So XaaS can be considered as broad network access. If you know, this is a characteristics of cloud. Cloud provides you broad network access. Can anybody tell what is the meaning of broad network access? We discussed already. What do you mean by broad network access? What are the five characteristics we have studied? Can anybody tell? First one is on-demand self-service. Second one is broad network access.
Sir, then it's resource pooling.
Exactly.
And
Next,
fourth one is measured service, and the
And
fifth
fifth-
one is rapid elasticity.
scalability, right? Rapid elasticity, scalability, right? So here you can see, in order to build a XaaS model, they took two different characteristics. One is called as broad network access. Resource pooling. Broad network access says that any device, there is no limit in the device. Any device connected to internet, right? You can use for getting the service. That it be your small smartphone, or you can say low-end smartphone, or it may be a PC, or it may be a workstation, or it may be a supercomputer also. You can get the service. Resource pooling means, you know, there is a large pool of resources from which you are getting the services. In addition to this, what you need, business-driven infrastructure on demand, because most of the companies are providing these services. Okay, they are business-oriented. That's why in high-level architectural design, I told you about. They look into stakeholders. They look into compliances, rules and regulations. They look into what is the ownership cost. Based upon that, they are taking decisions. Similarly, we have service orientations. These are coming under our SOI. Okay. So if you combine these four, right? SOI is our service oriented infrastructure, right? So if you combine these, we can get XaaS. XaaS fulfill all these four demands, right? If you want to integrate these four, then you can build a XaaS service. Now, if you go for classical service, like if you compare with a DOM terminal, the DOM terminal, in case of DOM terminal, all the responsibilities handled by that terminal. You cannot segregate IaaS, PaaS, and SaaS. So all the layer, hardware, operating system, hardware you can say IaaS, right? Operating system and development tools, you can say platform as a service. Application, you can say software as a service. It is managed by user only. Okay, if anything, any problem happen, then it will be solved by the user itself. So for classical service model, you have to pay more. Like you have purchased a particular server, workstation, or a computer system, you have to initially invest much amount. So IT budget and resource cost is you have to pay initially. And user also bears any cost related to maintenance, any cost related to technology. Suppose you have an outdated processor, you want to replace that processor with any updated processor. And what you have to do? Again, you have to pay the cost. And each system is designed and funded for a specific business activity. Okay. Each system is designed for a specific type of applications. If the application is changed, then again you have to pay the cost. And systems are deployed as a vertical stack of layers. Traditional systems are just like a vertical systems. You are adding one after another. which is not a good solution because it is tightly coupled. If something happened to one component, it is going to impact other components as well. So no single part can be easily replaced and changed. That's why today we are looking for microservices. Microservices will help you when a particular node, particular unit or component require maintenance. It is not going to impact other components because they are loosely coupled, they are lightweight. But if you go for vertical scaling or vertical stack of layers, when they are dependent on each other, so there is no single part can be easily replaced and changed. Similarly, prevalent of manual operations for provisioning and management. In order to give resources, in order to provide resources, in order to manage the resources, you require human intervention. That means manual operations are there. Autonomic service management you cannot achieve by the help of classical service model. And more or less, you can say it is a legacy IT, that is outdated ID. That's why classical service model is not suitable. Because you can see here, starting from the network to the application, each and everything is managed by our classical our user, right? User maintain this classical infrastructure. Now, coming to the key impact of cloud computing for IT functions, you can see both sides. You have a stack. Cloud case also you have a stack. Legacy IT case also you have a stack. So today we say green IT. Green IT we say because the energy requirement in the traditional system is more, but today's system we have less energy. Like here you can see end user devices we have, applications we have, dedicated infrastructure we have, if you go from top to bottom, and they are more or less dependent on each other. But when you go for evergreen IT or cloud-based system, you can see the dependency is as minimum as possible. Okay, there is no such dependency. They are not related. They are not completely, you can say, tightly coupled. If they are tightly coupled, then again there is an issue. Right? That's why I told you instead of going for vertical scaling, you can go for horizontal scaling. Right? That will give you a overall better environment than other environments. Right? Similarly, here you can see if you compare classic model with XaaS, like a traditional case, we are looking for licensed software. Like Windows, we are installing in our system. Over a period of time, if you are not updating, you are using pirated systems. If it is not supported, then you are going for pirated systems, right? But when you go for cloud, your cloud service provider has to take care of these things, this licensing part. Similarly, hardware products are outdated over a period of time, right? Nowadays, if you say somebody, I'm using a 256 MB RAM or 512 MB of RAM, then everybody will look, right? This is a legacy system, old outdated system. So you have to install at least 2 GB of RAM, right? Our mobile phones are having now also minimum 2 GB of RAM, right? So in the hardware product case also, in traditional case, user has to maintain this thing, which is also not a good solution. Similarly, people-based services, right? Like if you go for any professional services, it is not practically possible, right? You have to do a lot of things with respect to that particular service, right? But if you go for cloud, your cloud service provider has to take care of these things. Like many traditional companies, they are also using the legacy system, outdated systems, right? Like if you see our IRCTC side also, before a couple of years, they are having only 256 MB or 512 MB of RAM. So which is difficult to process the things. But now we have a high-end processor, that's why it is much more faster. Okay, in comparison to your classical model, you can see XaaS has a lot of features, like we have Amazon EC2, we have Amazon Web Services, we have Salesforce.com. These all are providing as a integrated service, IaaS, PaaS, and SaaS. So we are getting better services in comparison to the classic model. Okay, let us stop here. In the next class, we will see the details related to other topics. But if you have